What if everything we think we know about history is missing a crucial piece of the puzzle? Picture this: deep in the jungles of South America, a massive stone structure stands untouched for thousands of years, its blocks cut with such precision that not even a sheet of paper can slide between them. No mortar, no modern tools, yet it defies erosion, earthquakes, and time itself. How? This isn't just a mystery, it's a glaring clue that ancient civilizations might have possessed knowledge far beyond what we've ever given them credit for. From the towering pyramids of Egypt to the intricate machinery recovered from shipwrecks in the Mediterranean, the evidence is everywhere, scattered across the globe, whispering secrets of forgotten technologies. These weren't primitive societies stumbling through the dark ages of human progress. They were innovators, engineers, and visionaries who achieved feats that still baffle modern scientists. Think about it. How did the ancients align their monuments with celestial bodies down to the millimeter without satellites or computers? How did they manipulate stone like it was soft clay, or create batteries millennia before electricity was supposedly discovered? Today, we're pulling back the curtain on 25 ancient civilizations that shattered the limits of what we thought was possible. This isn't just a list, it's a journey into the heart of human ingenuity, where every discovery forces us to rethink the timeline of progress. These cultures didn't just exist, they thrived, built, and invented in ways that challenge our very understanding of history. So if you've ever wondered whether the past holds forgotten marvels, buckle up. Because by the end of this exploration, you'll see the ancient world in a light so startling, it might just change everything. The Sumerians weren't just the world's first civilization. They were pioneers who laid the groundwork for human knowledge in ways that still echo today. Nestled between the Tigris and Euphrates rivers, their cities thrived over 5,000 years ago, yet their achievements read like a catalogue of modern ingenuity. Take their grasp of astronomy. These weren't just stargazers. They mapped the movements of planets with such accuracy that their lunar calendar was only off by a fraction of a second per year. They tracked Venus, charted constellations, and even documented celestial events we've only recently decoded with high-powered telescopes. Then there's mathematics. The Sumerians didn't just count, they engineered a base 60 system. That's why we still have 60 seconds in a minute and 360 degrees in a circle today. They used geometry to survey land, calculate harvest yields, and even design their towering ziggurats with precision that defies their era. But perhaps their most revolutionary leap was cuneiform, the world's first writing system. What began as simple pictographs etched into clay tablets evolved into a complex script capable of recording laws, literature, and even receipts. That's right, the oldest surviving written documents aren't grand epics, but invoices for sheep and beer. But here's where it gets even more fascinating. Their irrigation systems transformed barren land into fertile fields with a network of canals so advanced, some historians argue they rival modern hydraulic engineering. And metallurgy, Sumerian artifacts reveal alloys and casting techniques that shouldn't have existed for another 2,000 years. A dagger uncovered in the ruins of Ur, for instance, wasn't just bronze. It was an expertly balanced blend of copper and arsenic, crafted with a sophistication that leaves archaeologists baffled. So why does this matter? Because the Sumerians weren't just ahead of their time, they seem to have leaped over entire epochs of human development. Their knowledge didn't crawl forward, it exploded as if someone handed them a blueprint for civilization. And that's the real mystery. Did they discover these breakthroughs through trial and error, or was there something, or someone guiding their ascent? Either way, one thing's clear. When we talk about ancient technology, the Sumerians weren't just players. They wrote the rule book. The Sumerians didn't just observe the stars, they mapped the heavens with a precision that still leaves astronomers stunned. Their clay tablets reveal an intricate understanding of celestial patterns, tracking planets like Venus with an accuracy that shouldn't have been possible without telescopes. One tablet, known as the Venus tablet of Amasajuka, records the planet's movements over a 21-year cycle, predicting its appearances and disappearances to within hours. How did they achieve this? Some researchers believe they used a combination of meticulous long-term observation and mathematical models far ahead of their time. Then there's the zodiac. Centuries before the Greeks formalized it, the Sumerians had already divided the sky into 12 sections, each tied to specific constellations. But here's the twist: their zodiac wasn't just for astrology. It served as a celestial calendar guiding agricultural cycles and religious festivals with uncanny precision. They even accounted for the slow wobble of Earth's axis, a phenomenon called precession, which takes 26,000 years to complete a full cycle. The fact that they noticed this subtle shift suggests an observational prowess bordering on the supernatural, but the real shocker lies in their possible grasp of planetary mechanics. Some tablets describe celestial bodies moving in loops, a term modern scholars interpret as retrograde motion, the apparent backward movement of planets like Mars as Earth overtakes them in orbit. For a civilization without advanced optics to recognize this phenomenon is nothing short of revolutionary. Even more tantalizing are scattered references to 7 wanderers, likely the Sun, Moon, and 5 visible planets, hinting at a heliocentric awareness long before Copernicus. So what's the explanation? Were the Sumerians simply the world's most patient sky watchers, or did they inherit knowledge from an even older, lost civilization? Their writings speak of the Apkallu semi-divine beings who supposedly gifted them wisdom. Myth or not, one thing's certain: when you look up at the night sky today, you're seeing it through the eyes of scribes who 5 millennia ago cracked codes we're still deciphering. While the Sumerians were mapping the stars, another civilization was engineering stone into eternity. The ancient Egyptians didn't just build tombs, they constructed monuments that defy physics, medicine that rivals modern practices, and mathematical systems so precise we're still unraveling their secrets today. Take the Great Pyramid of Giza. This isn't just a pile of rocks, it's a 2.5 million block precision instrument aligned to true north with an error margin of just 3/60ths of a degree. To put that in perspective, modern builders using laser-guided tools struggle to achieve that level of accuracy. And here's the kicker: each block weighs as much as 2 SUVs, yet they're fitted together so tightly you can't slide a credit card between them. But the pyramids are just the tip of the obelisk. The Egyptians mastered anatomy in ways that shouldn't have been possible without X-rays or microscopes. Their medical papyri detail surgical procedures for everything from brain trauma to setting broken bones, with remedies that modern studies confirm have genuine antibacterial properties. The Edwin Smith Papyrus, for instance, describes suturing wounds with thread and sterilizing tools with honey, a practice now known to prevent infection. They even performed cataract surgery using hollow needles, a technique still used today. Then there's their math. The Rind mathematical papyrus reveals they calculated areas, volumes, and slopes using fractions and algebraic equations centuries before Greece formalized geometry. But their most startling innovation was the Sikh, a unit of measurement that allowed them to maintain perfect pyramid angles across varying base sizes. It's essentially an ancient trigonometry table, proving they understood advanced principles long before Pythagoras was born. What's truly unsettling? The methods behind these feats vanish from their own records. No hieroglyphs explain how they moved 100-ton granite slabs from quarries 500 miles away, or how their physicians diagnosed diseases invisible to the naked eye. It's as if their greatest knowledge was either lost or deliberately kept hidden. One thing's certain: when we walk through museum halls admiring their artifacts, we're not just looking at relics. We're staring at fragments of a science we've yet to fully rediscover. The mystery of how the Egyptians moved and shaped their colossal stone blocks has baffled engineers for centuries. Conventional theories suggest ramp systems and wooden sledges, but when you examine the numbers, these explanations start to unravel. Take the Great Pyramid's granite blocks, some weighing 70 tons hauled from quarries over 500 miles away. Even with modern machinery, transporting stones of that size would be a logistical nightmare. Yet hieroglyphs show workers using nothing but ropes, sledges, and manpower. How some researchers point to the wetting the sand theory, pouring water before sledges to reduce friction. Experiments prove this cuts pulling effort by half, but it still doesn't fully explain how they maneuvered blocks up steep inclines without pulleys or cranes. Then there's the precision. The pyramid stones weren't just stacked, they were interlocked with tongue and groove joints, some featuring drill holes so perfect they suggest rotary tools harder than copper. Modern tests show their diorite and granite blocks required diamond-tipped drills to achieve such smooth bores, but diamonds weren't mined in Egypt until millennia later. So what were they using? A fringe but compelling theory involves the Baghdad battery, a clay pot found in Mesopotamia containing an iron rod and acidic residue, capable of generating a weak electrical charge. Could the Egyptians have harnessed electroplating to coat tools with ultra-hard materials? Even more puzzling are the megalithic temples like Karnak, where 100-ton lintels were lifted 60 feet in the air. No ramp system could feasibly reach those heights without collapsing under its own weight. Alternative theories propose harmonic vibration or even acoustic levitation techniques described in later Arabic texts, claiming the ancients used tuned rods to make stones weightless. While it sounds fantastical, ultrasound experiments today can reduce friction by 90%, lending eerie plausibility to the idea. Perhaps the most tantalizing clue lies in the unfinished obelisk at Aswan. This 1,000-ton monument, abandoned mid-construction, reveals tool marks suggesting they were shaping granite like butter. Nearby, researchers found dolerite-pounding stones, yet these would have taken decades to carve even a single obelisk. The math doesn't add up unless they possessed a lost method like heat treatment or chemical softening, hinted at in obscure papyri referencing fire that does not burn. So where does this leave us? Either we've drastically underestimated ancient ingenuity, or fragments of their technology vanished from history. The deeper we dig, the more Egypt's engineering marvels resemble not just tombs and temples, but a cryptic message, a challenge carved in stone, waiting for us to decipher its secrets. Buried beneath the sands of modern-day Pakistan and India lies a metropolis so meticulously planned. It puts some of today's cities to shame. The Indus Valley civilization flourished over 4,000 years ago, yet their urban blueprints reveal a level of sophistication that shouldn't have existed in the Bronze Age. Walk through the ruins of Mohenjo-Daro or Harappa, and you're not just seeing ancient streets, you're stepping into a grid system so precise, it could have been designed by a modern civil engineer. Every block aligns at perfect right angles, with main avenues wide enough for two carts to pass and secondary lanes branching off like veins in a leaf. But here's what's truly astonishing. These cities were built with a sewer system that wouldn't become standard in Europe for another 3,000 years. Beneath those orderly streets ran a network of brick-lined drains, each sloped to ensure waste flowed efficiently toward covered cesspits. Every home had its own bathing area with a sophisticated drainage system that connected to these main channels. Some even featured terracotta pipes with inspection holes for maintenance. In an era when most cultures were dumping waste into open trenches, the Indus people engineered a sanitation system that rivals modern plumbing. Archaeologists have found evidence of garbage chutes, street-side bins, and even public baths like the famed Great Bath of Mohenjo-Daro, a waterproofed marvel filled by an elaborate well system. But their genius didn't stop at infrastructure. Dig into any Indus marketplace and you'll find standardized weights made of polished chert, cubes and spheres so uniform, they vary by less than 1% across sites hundreds of miles apart. These weren't rough estimates. Traders used a precise binary system where weights doubled in perfect sequence, from tiny fractions for spices to heavy stones for bulk goods. Even their bricks followed a rigid ratio, every single one molded to identical dimensions of 4 by 2 by 1, a standard enforced across the entire civilization. What's most perplexing isn't just their advancements, but the silence surrounding them. Unlike the Egyptians or Sumerians, the Indus left no grand temples or royal tombs, just endless rows of nearly identical houses, suggesting a society that valued equality over hierarchy. Their undeciphered script, etched on thousands of seals, hints at complex trade networks stretching from Mesopotamia to Afghanistan. Yet we still don't know how they governed such a vast, orderly empire without obvious palaces or fortresses. Perhaps the greatest clue lies in what's missing. There's no evidence of war, no weapons beyond simple hunting tools, just cities built to last centuries, then abandoned mysteriously as the rivers shifted. Were they architects of utopia, or did they possess a forgotten philosophy that prioritized collective well-being over individual power? One thing's certain, when we look at their ruins, we're not just seeing an ancient culture. We're glimpsing a blueprint for civilization that modernity is still struggling to match. High in the jungles of Mesoamerica, the Maya weren't just stargazers, they were cosmic architects who built a civilization in perfect sync with the heavens. Their calendar system wasn't just a way to mark days. It was a multi-layered masterpiece of timekeeping so precise, it's more accurate than the Gregorian calendar we use today. At its core lay the long count, a linear measurement of time spanning over 5,000 years, broken into cycles that mirrored the rhythms of the universe. But here's what's truly mind-bending. They calculated planetary movements down to the minute, predicting eclipses centuries in advance without telescopes or computers. Their secret, observatories like El Caracol at Chichen Itza, a spiral tower with narrow windows aligned to Venus's most extreme rising and setting points. The Maya didn't just track this planet, they worshipped it as a god, basing wars and coronations on its 8-year cycle. Their Dresden Codex, a bark paper book surviving centuries of humidity, contains tables forecasting lunar eclipses and even corrections for the slight drift in Venus's orbit, a feat requiring observations over generations. Then there's their math. While Europe clung to Roman numerals, the Maya invented the concept of zero as a placeholder, using a shell glyph to represent nothingness, a leap in abstraction that revolutionized calculations. Their base 20 system, likely counting fingers and toes, let them handle numbers into the millions. Inscriptions at places like Palenque show dates stretching billions of years into the past and future, suggesting they saw time as infinite, cyclical, and meticulously measurable. But the real shocker comes from their celestial math. At Capon, a stairway of hieroglyphs documents a lunar cycle lasting 29.53086 days, off from modern measurements by just 34 seconds. How some scholars argue they used an intricate system of corrective tables, adjusting for errors over centuries like ancient programmers debugging cosmic code. What's haunting is how abruptly this knowledge faded. By the time Spanish ships arrived, the great observatories were already swallowed by jungle, their books burned as heresy. Yet even in fragments, the Maya's legacy whispers a truth. They didn't just watch the sky, they spoke its language, and we're still struggling to translate it all. Beneath the towering pyramids and celestial observatories, the Maya engineered a hidden marvel, a hydraulic network so advanced it turned jungle and limestone into a thriving metropolis. While modern cities struggle with water shortages, the Maya sustained populations in the tens of thousands in places where rainfall was erratic and rivers scarce. Take Tikal, a city-state buried deep in the Guatemalan rainforest. With no natural lakes or rivers nearby, survival should have been impossible. Yet archaeologists have uncovered a labyrinth of reservoirs, canals, and filtration systems that held millions of gallons of water, enough to support 60,000 people through months of drought. These weren't just holes in the ground. The Maya lined their reservoirs with layers of clay and crushed limestone, creating waterproof seals that prevented leakage. They engineered subtle slopes to channel rainwater from plastered plazas and temple roofs into these storage systems, turning entire cityscapes into catchment areas. But here's the real innovation: their water wasn't stagnant. At Paylink, engineers designed gravity-fed aqueducts that redirected spring water through underground channels, some pressurized enough to create fountains. They even built settling tanks with woven fiber filters to purify water before it reached drinking reservoirs, a rudimentary but effective precursor to modern treatment plants. Then there's the mystery of the Bojo wetlands. Satellite imagery reveals grids of raised fields spanning hundreds of miles, where the Maya transformed seasonal swamps into fertile farmland. By digging canals between planting beds, they created a self-regulating system. The canals trapped nutrient-rich silt during floods, while the water table kept crops hydrated in dry seasons. Experiments show these fields could yield harvests 3 times denser than traditional slash-and-burn methods, all without chemical fertilizers. What's most astonishing isn't just their technology, but their foresight. At Edsna, hydraulic engineers designed a network so precise it could redirect water during storms to prevent flooding, then store excess for lean times. They even factored in evaporation rates, shading reservoirs with trees to reduce water loss. This wasn't guesswork, it was hydroengineering backed by centuries of meteorological observation. Yet, like so much of Mayan knowledge, these systems vanished with their decline. Overgrown canals and silted reservoirs hint at a civilization that mastered water only to see it slip through their fingers. Perhaps the lesson lies not in how they built, but in why they fell, a warning etched in stone and earth about the delicate balance between human ingenuity and nature's limits. While the Maya charted the heavens across the Pacific, the ancient Chinese were quietly revolutionizing human civilization with breakthroughs that would shape global history. Their inventions didn't just change their own society, they altered the trajectory of humanity itself. Take paper, a deceptively simple innovation that replaced bulky bamboo slips and expensive silk scrolls. Invented during the Han Dynasty around 105 BC, this wasn't just pulp and water. It was a carefully engineered material made from mulberry bark, hemp, and rags, beaten into sheets so durable that manuscripts survive today, 2,000 years later. But here's what's often overlooked. Papermaking was an industrial-scale process involving soaking, steaming, and pressing fibers through screens, a level of chemical understanding far ahead of its time. Then there's gunpowder, an accidental discovery by alchemists searching for immortality. By mixing saltpeter, sulfur, and charcoal, they unleashed a force that would redefine warfare, but that's only part of the story. Early Chinese texts describe flying fire, arrows tipped with gunpowder tubes that acted like primitive rockets, and earth thunder, bombs hurled from catapults during sieges. By the 1300s, they developed multi-stage rockets with wooden fins for stability, a design principle still used in modern aeronautics. Yet beyond destruction, gunpowder revolutionized mining and construction, allowing workers to blast through rock where chisels would have taken years. The compass, another game-changer, began as a divination tool, a lodestone spoon spinning on a bronze plate. But by the Song dynasty, navigators were floating magnetized needles in bowls of water, creating instruments so precise they enabled maritime trade routes stretching to East Africa. These weren't crude pointers. Ship logs describe compasses with 32 directional markers, allowing sailors to correct for magnetic deviation centuries before Europe understood the concept. But perhaps their most underrated achievement lies in metallurgy. While the West struggled with brittle iron, Chinese foundries were producing high-carbon steel through complex, quenching and tempering techniques as early as 200 BC. The Qin dynasty's bronze swords, unearthed with the terracotta army, still gleam with chromium oxide coatings, an anti-rust treatment not replicated in the West until the 1900s. Their blast furnaces, fueled by piston bellows, reached temperatures over 1,300 degrees Celsius, producing cast iron on an industrial scale while Europe remained stuck in the Bronze Age. What ties these innovations together isn't just ingenuity, but a systematic approach to knowledge. The Chinese didn't see science, art, and philosophy as separate fields. They wove them into a unified worldview where every discovery served both practical and cosmic harmony. When a Song dynasty scholar invented movable type printing, it wasn't just a technical feat. It was a way to spread wisdom, aligning with Confucian ideals of education. Even gunpowder, for all its destructive power, became part of New Year celebrations, lighting up the sky in displays meant to scare away evil spirits. So why does this matter today? Because these weren't isolated gadgets, they were the foundation stones of modernity. Paper became the medium for global communication, compasses unlocked the age of exploration, and gunpowder reshaped nations. Yet the real lesson lies in how these inventions emerged not from lone geniuses, but from a culture that valued observation, experimentation, and the relentless refinement of ideas. The ancient Chinese didn't just make things, they taught the world how to think forward. The Minoans didn't just build ships, they mastered the sea with vessels so advanced they dominated Mediterranean trade for centuries. Nestled on the island of Crete, this Bronze Age civilization crafted sleek, ocean-going galleys with reinforced hulls and towering masts, capable of hauling tons of cargo across hundreds of miles. Archaeological finds revealed docking facilities at ports like Como's, where stone piers and storage magazines hint at a maritime network stretching from Egypt to Sardinia. But what sets their ships apart aren't just their size, it's their design. Frescoes from Akrotiri show vessels with crescent-shaped hulls, a hydrodynamic innovation that reduced drag and increased speed. These weren't simple fishing boats, they were the freighters of their day, equipped with cabins for crew and even rudimentary navigation tools like lead weights for measuring depth. Then there's Knossos, the labyrinthine palace that defies its era. Forget dark, cramped corridors, this was a multi-story complex with light wells, ventilated courtyards, and a plumbing system that put medieval Europe to shame. Clay pipes built with a slight gradient carried fresh water from mountain springs into bathrooms and even flush toilets, while terracotta drains disposed of waste through an underground network. Some rooms featured adjustable wooden louvers to control airflow, an ancient precursor to modern HVAC. The precision of their engineering is staggering. Sections of the palace's drainage system still function today, 4,000 years after they were laid. But the most tantalizing mystery surrounds their sudden collapse. Around 1450 BC, Thera, a volcanic island 70 miles north, erupted with a force 10 times greater than Krakatoa. Tsunamis devastated coastal cities while ash blotted out the sun for years. Yet some researchers argue the Minoans were already in decline, their trade networks faltering. Legends whisper of a greater cataclysm, Plato's account of Atlantis, a seafaring empire that sank beneath the waves. Strikingly, his descriptions of concentric city rings and advanced engineering align eerily with Minoan ruins. Could Thera's destruction have inspired the myth? Artifacts add fuel to the fire. The Minoans left behind intricate gold jewelry crafted with filigree techniques thought impossible before the Renaissance, and frescoes depicting bizarre, blue-skinned figures some speculate represent an unknown culture. Most haunting is the Phaistos disc, a clay tablet stamped with undeciphered symbols spiraling inward, a linguistic puzzle that, if solved, might rewrite history. Were the Minoans simply brilliant innovators or custodians of lost knowledge? their legacy lies not just in ruins but in the whispers of a civilization that danced with the sea and vanished into its depths. The ancient Greeks are often celebrated for their philosophy and democracy, but their technological brilliance rivals even their intellectual legacy. Hidden among their marble temples and poetic epics lies evidence of mechanical mastery centuries ahead of its time. Take the elusive eolipile, described by Hero of Alexandria in the 1st century, a hollow sphere mounted on a boiler that spun wildly when heated. This wasn't just a curiosity, it was the world's first recorded steam engine, harnessing thermal energy to produce motion over a millennium before the Industrial Revolution. Had the Greeks paired this with their knowledge of gears and levers, they might have sparked a mechanical renaissance 2,000 years early. Yet nothing compares to the Antikythera mechanism, a corroded bronze artifact recovered from a shipwreck in 1901 that rewrote history. Initially dismissed as a navigational tool, decades of imaging revealed an intricate system of 30 interlocking gears, precisely calibrated to track celestial movements. This wasn't just a clock, it was an analog computer capable of predicting lunar eclipses, Olympiads, and planetary positions with staggering accuracy. The smallest gears, some barely 2 millimeters wide, functioned as a differential, a component thought to have been invented in the 1600s. How did they achieve such precision without precision tools? X-rays show the gears were hand-cut from a single sheet of bronze using a template, their teeth painstakingly filed to exact angles. The device even accounted for the moon's elliptical orbit via a clever pin and slot mechanism, mimicking the irregularity we now know is caused by gravitational pull. This wasn't guesswork, it was the product of rigorous astronomical observation and metallurgical skill. Beyond the Antikythera, Greek workshops buzzed with automatons, mechanical puppets that danced when air rushed through hidden tubes, hydraulic-powered singing birds, and even robotic servants that poured wine. Archimedes, the era's greatest engineer, designed screw pumps still used today and reportedly built a heat ray weapon to set Roman ships ablaze with reflected sunlight. What stuns modern scholars isn't just their inventions but their mindset. The Greeks saw no divide between science and art. Their machines were both practical and poetic, reflecting a universe governed by mathematical harmony. Perhaps that's the real lesson hidden in those bronze gears. Progress isn't just about what you build, but how you imagine the possible. While the Greeks dazzled with mechanical wonders, their true revolution unfolded in the realm of ideas, a seismic shift in how humanity understood the natural world. Picture this, in the bustling agora of ancient Athens, philosophers didn't just debate abstract concepts, they dissected reality itself, laying intellectual foundations that would shape science for millennia. Thales of Miletus, often called the first scientist, didn't merely observe nature, he insisted phenomena like earthquakes had natural causes, not divine whims. When he predicted a solar eclipse in 585 BC, it wasn't magic, it was meticulous Babylonian astronomical data paired with bold reasoning. This marked humanity's first steps toward empirical inquiry. Democritus took it further, proposing everything was made of invisible, indivisible particles he called atomos. Without microscopes or labs, he envisioned a universe of swirling matter, a theory closer to modern quantum physics than to the four elements of his peers. Meanwhile, Pythagoras discovered mathematical harmony in vibrating strings, revealing music's hidden geometry. His cult-like followers didn't just worship numbers, they saw them as the universe's secret language, a concept echoing in today's string theory. But the crown jewel of Greek thought was Aristotle's Lyceum. Here, the philosopher compiled the first systematic studies of biology, dissecting hundreds of species to classify life by traits, an early taxonomy. His students recorded how cuttlefish change color and how chick embryos develop day by day, pioneering observational methods still used in labs. Even his errors were productive. His mistaken belief in spontaneous fermentation inspired later scientists to disprove it, birthing microbiology. Then there's Archimedes shouting "Eureka!" not just about buoyancy but calculus-like methods for measuring curves, and Eratosthenes, who calculated Earth's circumference with sticks and shadows off by less than 2%. Their genius wasn't isolated flashes, it was a culture that prized reasoned debate over dogma. The Alexandrian library became the ancient internet, where scholars cross-referenced Egyptian medicine, Babylonian astronomy, and Indian mathematics. Yet their legacy isn't just what they discovered, but how they thought. The Greeks taught us to question, experiment, and seek universal laws, tools more valuable than any artifact. When Newton stood on giants' shoulders, it was these minds he leaned on hardest. Their equations still govern planets, their logic underpins code, and their insatiable curiosity remains science's beating heart. The Romans didn't just build an empire, they engineered the ancient world's most enduring infrastructure, turning raw materials into masterpieces that still stand today. Walk through the heart of Rome, and you'll tread on roads laid 2,000 years ago, their cobblestones worn smooth by centuries of footsteps. These weren't just dirt paths. The Appian Way alone stretched 350 miles, linking Rome to Brindisi with a foundation of crushed stone, mortar, and volcanic ash so robust that sections remain usable. But the real genius lay beneath the surface, a carefully layered system of drainage ditches and cambered surfaces that sloped rainwater off the road, preventing erosion and mudslides. Every mile was marked with stone pillars denoting distances, while way stations provided fresh horses, making Rome's highways the ancient equivalent of an interstate system. Yet their most iconic innovations carried water, not travelers. The aqueducts were marvels of hydraulic engineering, some spanning 50 miles to deliver fresh mountain springs to bustling cities. Pont du Gard in France towers 160 feet high, its arches precisely calculated to distribute weight without mortar, just interlocking stones and gravity. But here's what's staggering. These channels had gradients as slight as 1 in 10,000, dropping just inches per mile to maintain a steady flow. Roman surveyors achieved this with chorobates, water-filled leveling tools, and groma devices to plot straight lines across valleys. The result, Rome's million citizens enjoyed as much water per capita as modern New Yorkers, flowing to public baths, fountains, and even private homes through lead pipes, an early example of municipal plumbing. Then there's the material that made it all possible, Roman concrete. While modern concrete crumbles in decades, their mixture of volcanic ash, lime, and seawater chemically bonded over time, growing stronger with exposure to the elements. Dive into the Mediterranean, and you'll find harbor walls like those at Caesarea, submerged for millennia yet intact, while scientists recently discovered their concrete contains rare minerals that self-heal cracks. This wasn't just durability. It was a recipe lost to history until labs began reverse engineering it in the 21st century. But Rome's engineering wasn't just about scale, it was about adaptability. Their rotating cranes, powered by treadmills, could hoist 20-ton columns, while hypocaust systems channeled hot air under floors for central heating. Even their entertainment showcased technical prowess. The Colosseum's retractable awning, the velarium, required 1,000 sailors to maneuver its ropes and pulleys, shading 80,000 spectators from the sun. What's most revealing isn't their inventions, but their philosophy. The Romans treated infrastructure as a civic duty, funding projects through taxes and conquest spoils. When they built for eternity, stamping their legacy not in scrolls alone, but in stone and water and road. Today, as modern engineers relearn their secrets, one truth emerges. Rome's real conquest wasn't just territory, it was time itself. Deep in the sweltering jungles of Veracruz, the Olmecs carved their legacy into stone literally. Their colossal heads, some weighing over 20 tons and standing 10 feet tall, aren't just monuments, they're riddles in basalt. Each one bears a distinct helmet, some resembling athletic headgear, others adorned with intricate symbols, leading scholars to debate whether they depict rulers, gods, or even players in a sacred ball game. But here's what defies logic. These sculptures were hauled from quarries 50 miles away through marshland and rainforest without wheels or draft animals. How? The prevailing theory involves log rollers and rafts, but recent experiments show moving even a fraction of that weight through such terrain would require hundreds of workers coordinating with near-military precision. Then there's the material itself. The Olmecs didn't just carve any rock, they used volcanic basalt from the Tuxtla Mountains, a stone so dense it blunts modern chisels after minutes of work. Yet their sculptures show no tool marks, only smooth curves and sharp details, suggesting techniques lost to time. Some researchers speculate they employed heat treatment, heating the stone's surface before chiseling to soften it, a method later used by the Egyptians. Others point to hematite mirrors found at Olmec sites, proposing they focused sunlight to etch designs, though no conclusive evidence exists. But the Olmecs' ingenuity didn't stop at stone. They were the first civilization in the Americas to harvest rubber, tapping sap from local Castilla elastica trees and mixing it with morning glory juice to create durable, bouncy balls. These weren't just toys, they were central to a ritual sport played on ceremonial courts, where the fate of captives sometimes hung on a game's outcome. Chemical analysis of rubber artifacts reveals a vulcanization process predating Goodyear's patent by 3 millennia. Their influence rippled across Mesoamerica like a stone dropped in water. The Maya inherited their calendrical system, the Zapotecs adopted their glyphic writing, and even the Aztecs revered Olmec sites as places of primordial power. At La Venta, buried beneath a pyramid, archaeologists found a mosaic floor depicting a jaguar mask, a design echoed centuries later in Teotihuacan's murals. Their art's hallmark were jaguar motif, blending human and feline traits, became a template for deities from Quetzalcoatl to the Mayas' rain god Choc. What's haunting is how little we know of their downfall. By 400 BC, their cities were abandoned, their monuments defaced. Some theories cite climate shifts or internal revolt, but the truth remains buried, much like the Olmecs' own practice of ritually burying their colossal heads, only to unearth them later in ceremonies we can scarcely comprehend. Their legacy whispers through the artifacts they left behind, not just as the mother culture of Mesoamerica, but as innovators who turned rubber into ritual and stone into sovereigns. In the heart of Jordan's blistering desert, the Nabateans didn't just survive, they thrived, sculpting an empire from sandstone and ingenuity. Their crown jewel, Petra, wasn't just a city, it was a hydrological masterpiece hidden in plain sight. Carved into rose-red cliffs, this metropolis flourished where rainfall averaged just 6 inches a year, relying on a water network so sophisticated, modern engineers still study its blueprints. The secret, a labyrinth of channels, cisterns, and dams that turned scarcity into abundance. Start with the Sick, Petra's dramatic entrance, a narrow gorge where Nabatean engineers cut nearly 200 channels into the rock walls. These weren't just gutters, they were precision sluices designed to capture every drop of seasonal floodwater, funneling it into a main pipeline that fed the city's reservoirs. Some channels were mere centimeters wide, calculated to slow water flow and minimize evaporation, while ceramic pipes buried beneath streets ensured distribution without loss. At its peak, Petra stored over 40 million gallons of water, enough to sustain 20,000 people through years of drought, but the real marvel lay in their disaster prevention. The Nabateans didn't just collect water, they tamed it. Wadi Musa, the valley leading to Petra, was prone to violent flash floods. Their solution, a series of diversion dams and spillways that redirected torrents away from the city while replenishing groundwater. One structure, the Dam of the Pharaohs, featured a curved design that dissipated hydraulic force, an innovation not seen again until the 1900s. Beyond Petra, their reach extended to arid outposts like Hegra in Saudi Arabia, where they terraced hillsides to channel runoff into agricultural plots, growing grapes and olives in soil that looks barren today. Their understanding of microclimates was so advanced, they placed cisterns in shaded crevices to keep water cool and lined them with waterproof plaster made from lime and ash. What's most haunting about the Nabateans is how little they left behind in writing. No treatises explain their methods. Their knowledge is etched into the landscape itself. Even their famous treasury, with its Hellenistic facade, hides a clue. Its upper cracks suggest it once functioned as a ceremonial water distribution point, symbolizing their belief that controlling water was divine. By the time Rome absorbed their kingdom in 106 CE, the Nabateans had already mastered something modern societies still grapple with: how to thrive in a world where water is both scarce and powerful. Their legacy isn't just in the ruins we admire, it's in the urgent lesson that survival in the desert or any harsh reality isn't about conquering nature. It's about listening to it. The Persians didn't just conquer vast territories, they mastered the art of sustaining them, turning arid deserts into thriving hubs of innovation. At the heart of their empire lay the Qanat, an underground water channel system so effective, it's still in use today across the Middle East. Picture this: beneath the scorching sands, engineers dug vertical shafts at intervals, connecting them with gently sloping tunnels that tapped into mountain aquifers. Gravity did the rest, guiding water over miles without a single drop lost to evaporation. These weren't just ditches, they were feats of precision. Surveyors used stars to align tunnels, ensuring the perfect gradient for steady flow. In cities like Gonabad, Qanats delivered cold, clean water to homes, bathhouses, and even ice houses, where winter's harvest was stored under insulating layers of straw and clay to last through summer. But water was only part of their genius. The Royal Road, stretching 1,600 miles from Susa to Sardis, became the ancient world's information superhighway. Courier stations dotted the route, each stocked with fresh horses so messages could race across the empire in days, not months. Herodotus marveled that neither snow nor rain slowed these riders, a proto-postal service that inspired everything from the Pony Express to modern logistics. The road wasn't just for speed, it was a tool of control, binding distant provinces to the imperial core with a speed unmatched until the railroads. Then there's the Yakchul, Persia's answer to refrigeration. These domed structures, some towering 60 feet high, harnessed the desert's extremes. At night, water channeled from Qanats froze in shallow pools, then was packed into the Yakchul's thick mud brick walls. Ventilation shafts drew hot air upward, while subterranean storage kept temperatures near freezing even in midsummer. It wasn't just about luxury. These ice houses preserved food, cooled royal palaces, and even supplied ice for the legendary Persian Falude dessert. What set the Persians apart wasn't just their inventions, but their vision. They saw infrastructure as a living network, weaving water, transport, and storage into a system that nurtured stability. While other empires hoarded gold, the Persians invested in knowledge. Their Qanat builders were exempt from military service, their road engineers celebrated as state treasures. In the end, their greatest legacy wasn't the land they ruled, but the ingenuity that made it flourish against all odds. While civilizations across the ancient world were tallying numbers with cumbersome symbols, the scholars of ancient India were quietly revolutionizing mathematics with a concept so fundamental, it now underpins every digital device on Earth: the decimal system. Unlike the Roman numerals or Babylonian base 60 calculations, Indian mathematicians introduced place value as early as 500 BCE, with the concept of zero as a numeral appearing in the Bakshali manuscript by the 3rd century. But this wasn't just a theoretical leap. Traders and astronomers adopted these numerals with stunning speed, calculating planetary positions and market transactions with unprecedented efficiency. The famous Aryabhata, writing in 499 CE, didn't just use zero, he treated it as a dynamic entity, describing the square of negatives and the motion of celestial bodies with equations that wouldn't reach Europe for another 1,000 years. Their surgical prowess was equally groundbreaking. The Sushruta Samhita, a 6th century BC text, reads like a modern medical manual except it was written on palm leaves. Sushruta, often called the father of surgery, detailed over 300 procedures, from cataract removal using curved needles to reconstructive rhinoplasty, where skin grafts were taken from the forehead to repair noses lost in battle or punishment. But what's truly astonishing is their understanding of antisepsis. The text instructs surgeons to boil instruments and use fumigation with aromatic herbs, anticipating germ theory by millennia. They even classified bones, muscles, and joints with a precision that mirrors contemporary anatomy, all while advocating for ethical practices like informed consent and patient aftercare. Beyond scalpels and numbers, their metallurgy defied eras. The iron pillar of Delhi, erected in 400 CE, stands rust-free after 1600 monsoons, a feat modern science only recently decoded. The pillar's high phosphorus content creates a protective patina, a secret lost until 20th century labs rediscovered it. Similarly, their Wootz steel, forged from unique carburization techniques, produced blades so flexible and sharp they became legendary across Persia and Arabia. When these swords reached Damascus, Middle Eastern smiths spent centuries trying and failing to replicate their diamond-like patterns and resilience. What unites these achievements is a culture that saw no divide between science and spirituality. Mathematical breakthroughs were penned in poetic verse, surgical tools were consecrated like sacred objects, and observatories doubled as temples. Perhaps that's the real lesson etched into those ancient palm leaves, and rustless iron progress isn't just about discovery, but about weaving knowledge into the very fabric of life. The Mesopotamians didn't just invent the wheel, they set civilization in motion. 5,000 years ago, while other cultures dragged goods on sledges, Sumerian potters mounted clay discs on axles, creating the world's first known wheels. But their breakthrough wasn't just about mobility. By 3500 BC, they'd scaled this innovation into war chariots with spoked wheels, revolutionizing transportation and warfare across the Fertile Crescent. Archaeologists at unearthed chariots buried with kings, their wheels still bearing traces of leather tires, a staggering leap from simple carts. Yet their true genius lay in codifying order from chaos. The Code of Hammurabi, etched on a towering diorite stele, wasn't just a list of laws, it was a societal operating system. 282 clauses covered everything from property disputes to medical malpractice, introducing concepts like innocent until proven guilty and standardized wages. A surgeon's fee for a successful operation, 10 silver shekels, but make one fatal mistake and the penalty was losing a hand. Brutal, perhaps, but this wasn't arbitrary cruelty. It was a calculated trade-off where predictability mattered more than mercy, stabilizing a melting pot empire of Akkadians, Amorites, and Sumerians. Meanwhile, their fields flourished through hydraulic wizardry. The Mesopotamians transformed the marshy Tigris-Euphrates delta into a breadbasket with an irrigation network so precise, it's echoed in modern rice paddies. Circular seed plows pulled by oxen planted rows in perfect arcs, while shaddufs counterweighted buckets on pivoting arms lifted water from canals to higher fields. At Nippur, cuneiform tablets record crop rotation schedules and soil salinity tests, proving they understood sustainable farming millennia before the term existed. Their most underrated innovation, accounting. Temple scribes tracking sheep and grain inventories developed cuneiform into a numerical system capable of complex loans and interest calculations. One tablet from Lhasa details a compound interest loan paid in silver over 5 years, an early form of banking that funded trade expeditions to India and Afghanistan. What made Mesopotamia extraordinary wasn't any single invention, but how they wove them together. Wheels moved goods to markets governed by laws, irrigated fields fed the workers who built cities, and written records turned barter into commerce. This wasn't just progress, it was the birth of the interconnected world we still inhabit today. Long before samurai swords became legendary, the ancient Japanese were forging steel with techniques that blurred the line between metallurgy and art. In the quiet mountains of the Yamato region, blacksmiths of the Kofun period perfected the tatara method, a process so precise it could transform iron sand into steel with a purity modern factories struggle to match. Picture this: craftsmen piled layers of black satetsu sand into clay furnaces, then burned charcoal for 3 days and nights at temperatures exceeding 2,500 degrees Fahrenheit. The result, a spongy mass called kira, which masters would fold and hammer over 1,000 times, drawing out impurities while weaving carbon into the metal's very grain. This wasn't just smithing, it was alchemy, producing blades so resilient they could slice through armor without losing their edge. Yet the real mystery lies in the Dorak artifacts, a collection of bronze and jade objects unearthed in the 1960s, adorned with motifs unlike anything seen in Japan's archaeological record. Among them, a ceremonial dagger bears swirling patterns identical to designs found in ancient Silla, Korea, while a headdress mirrors Siberian shamanic regalia. Most baffling is a small plaque depicting a chariot race, a scene straight from Greek mythology, thousands of miles and centuries removed from Japan's insular cultures. How did these objects end up in a burial mound near the Seto Inland Sea? Some scholars argue they're evidence of the Jomon people's vast trade networks, stretching across land bridges now submerged beneath the Tsushima Strait. Others whisper of the Amishi, a mysterious ethnic group described in Nihon Shoki chronicles as hairy barbarians who may have bridged continental and island cultures. The artifact's craftsmanship only deepens the enigma. Their bronze contains trace alloys matching ores from the Altai Mountains, while the jade's nephrite composition points to sources in modern-day Inner Mongolia. What emerges from these fragments is a portrait of ancient Japan far more connected than history books suggest. The Tatara stele speaks of a people who harnessed fire and earth to create peerless weapons, while the Dorak treasures hint at crossroads we're only beginning to map. Together, they shatter the myth of isolation, revealing an archipelago where continental winds carried not just goods, but ideas that shaped a civilization. The ancient Celts weren't just fierce warriors, they were master engineers whose innovations whisper of knowledge far ahead of their time. Take their metalwork. While Rome celebrated gold and silver, Celtic smiths were forging weapons and jewelry with techniques that still baffle modern metallurgists. The Battersea Shield, dredged from London's Thames River, isn't just bronze, it's a masterpiece of repoussé artistry, hammered from behind to create intricate raised patterns. But the real shocker lies beneath the surface. X-rays reveal microscopic layers of different alloys, strategically placed to make the shield both lightweight and indestructible. Some torques and armbands show evidence of zinc plating, a process not officially discovered until the 1800s. How did they achieve this without electrolysis? One controversial theory points to the Baghdad battery, a clay pot found in Mesopotamia capable of generating a weak charge. Could the Celts have harnessed similar technology, or did they stumble upon another lost method? Their calendar systems reveal another layer of sophistication. The Coligny calendar, a fragmented bronze plaque discovered in France, isn't just a lunar tracker. It's a complex interlocking system reconciling solar and lunar cycles over 30 years. Unlike the rigid Roman calendar, it accounts for seasonal drift by inserting extra months in precise sequences, matching celestial events with eerie accuracy. Even more astounding are the symbols etched beside certain dates, small spiral designs some researchers interpret as warnings for eclipses or planetary alignments. This wasn't just timekeeping, it was celestial programming encoded in bronze by druids who watched the skies as closely as any modern astronomer. Then there's the baffling discovery at the tomb of Hochdorf. Buried beneath a German mound, a Celtic chieftain lay on a bronze couch adorned with unmistakable iron rivets, except these weren't ordinary nails. Microscopic analysis shows they contain traces of sulfuric acid, a byproduct of electrochemical reactions. Nearby, archaeologists found strange clay vessels with copper and iron inserts, their interiors stained with acidic residue, the mainstream explanation. Ritual offerings, but fringe scholars propose an alternative: primitive batteries, possibly used for electroplating jewelry or even medical purposes. Ancient texts reference druidic healing rods that produced tingling sensations when touched to wounds, a sensation eerily similar to low-voltage current. What ties these threads together is a culture that saw no divide between art, science, and the sacred. A Celtic smith didn't just shape metal, he chanted spells into the molten ore, believing words could alter its strength. Their calendar wasn't mere math, it was a sacred covenant with the cosmos, and if they did harness electricity, it likely wasn't seen as technology but magic, a force as mysterious to them as quantum physics is to us. The Celts left no libraries to explain their secrets, only artifacts that gleam with unanswered questions, daring us to rethink what ancient truly means. The ancient Polynesians didn't just sail, they danced with the ocean, reading its rhythms like a language written in stars and swells. Picture a wooden outrigger canoe cutting through Pacific darkness, its crew navigating thousands of miles without compasses or charts. These voyagers memorized the night sky's shifting tapestry, tracking over 220 stars by name and position. The star line known as Ki Ka guided them to Hawaii, while Te Mankoroa pointed toward New Zealand. But their celestial map was only part of the story. They watched how clouds clustered over distant islands, how certain seabirds only flew a set range from land, and how waves refracting off unseen shores created subtle patterns in the swell. Their most ingenious tool, the Te Lapa underwater lightning. Modern science describes this phenomenon as bioluminescent streaks caused by deep ocean currents striking submerged reefs, visible only to trained eyes on moonless nights. Polynesian navigators could spot these faint blue-green trails from miles away, following them like submerged highways to unseen islands. They also relied on kino, the art of wayfinding, where navigators would lie across canoe hulls, feeling wave vibrations through their bones to detect land masses disrupting ocean currents. Perhaps most astonishing was their mental mapping. Using sticks and shells, navigators like the legendary Maupiailog could reconstruct entire sections of the Pacific from memory, accounting for seasonal variations in wind and current. When European explorers discovered islands like Rapa Nui or Tahiti, they often found Polynesians already thriving there, having completed voyages that dwarfed Columbus's Atlantic crossing with none of his tools. What they achieved wasn't just navigation, it was a communion with nature's subtle cues, a testament to human adaptability. While Western ships clung to coastlines, Polynesian canoes embraced the open ocean's vastness, proving that true exploration begins not with conquering the unknown but listening to it. Carved into the volcanic highlands of northern Ethiopia, the rock-hewn churches of Lalibela stand as one of humanity's most astonishing architectural feats. 11 monolithic structures, each painstakingly chiseled downward from solid rock, form a sprawling spiritual complex often called the eighth wonder of the world. But these aren't just buildings, they're negative space sculptures, where artisans didn't add materials but removed them, working with a precision that defies their 12th century origins. Take the Church of St. George, its cross-shaped roof descending 40 feet into the earth, its windows and doorways aligned to catch the first rays of dawn during equinoxes. The interior pillars echo the rhythm of Aksumite architecture, yet their flawless symmetry suggests tools or techniques beyond what conventional history attributes to medieval Africa. What's even more perplexing is how these churches connect to an older, shadowy tradition. Local lore speaks of the Knights Templar assisting in their construction, while Ethiopian manuscripts reference the Kebra Nagast, a sacred text claiming the Ark of the Covenant was brought to Axum by Menelik I, son of King Solomon and the Queen of Sheba. Could Lalibella's builders have preserved fragments of Solomonic engineering? Some scholars point to the church's ventilation shafts uncannily similar to those in Egypt's Great Pyramid, and their advanced drainage systems which prevent flooding during torrential rains. Even the tools described in medieval accounts, like the meskel, a curved chisel, bear a striking resemblance to copper alloys used in much older Axumite obelisks. The mystery deepens when you examine the subterranean tunnels weaving beneath the complex. Narrow passageways, some stretching half a mile, link the churches in a network that echoes descriptions of Solomon's temple. Ground-penetrating radar has revealed chambers still unexcavated, fueling speculation about hidden archives or lost technologies. And then there's the town's original name, Roha, which some linguists connect to the Hebrew Ruha, meaning spirit, a hint, perhaps, at esoteric knowledge passed down through generations. But the most tantalizing clues lie in the artifacts. In the treasury of Axum's Church of Our Lady Mary of Zion, guarded by monks who permit no outsiders to enter, legends insist the Ark itself rests. While its existence remains unverified, other relics like the 15th century Galila Gospels, written on luminescent parchment that resists decay, hint at preservation methods science can't yet replicate. Even the Lalibela Church's acoustics baffle experts. Whisper at one end of Beta Mariam, and the sound carries clearly to the far corner, a phenomenon architects still struggle to explain without modern modeling. Were the builders of Lalibela inheritors of a forgotten technological tradition, or did they achieve these marvels through sheer devotion and ingenuity? The answer may lie in the very rock itself, a testament not just to faith, but to a civilization that carved its mysteries in stone, daring us to listen. High in the thin air of the Himalayas, the ancient Tibetans cultivated a medical tradition so advanced, it still influences modern healing practices. Their understanding of the human body wasn't just anatomical, it was energetic, mapping channels of vitality called tsar that mirrored the nervous system centuries before Western science discovered it. The Tibetan medical thankas, intricate scrolls painted with meticulous detail, depict everything from embryology to surgical procedures, but their true brilliance lies in their holistic approach. They diagnosed illnesses by reading pulses with a precision that could distinguish between 84 subtle variations, each tied to specific organs or imbalances. One text, the Jayushi, describes complex herbal compounds like agar 35, a blend of 35 ingredients used to treat everything from infections to heart disease. Formulations modern labs now confirm have potent anti-inflammatory and antimicrobial properties. But their most startling innovations involved mental health. Tibetan physicians prescribed meditation, dietary changes, and environmental adjustments centuries before the term psychosomatic medicine existed. They understood depression as a stagnation of lung life force energy, treating it with techniques like lung breathing exercises, methods eerily similar to modern cognitive behavioral therapy. Even more remarkable were their surgical practices. They used heated needles to cauterize wounds, sterilized tools with mercury compounds, and performed trepanations to relieve intracranial pressure, all while emphasizing the patient's emotional state as a critical factor in recovery. Beyond medicine, Tibet's landscape hides another enigma, the so-called pyramids of the Kang Rinpoche region. Towering stone structures, some exceeding 600 meters in height, rise in precise geometric formations near Mount Kailash, a mountain revered as the axis of the spiritual world. Unlike Egyptian pyramids, these weren't built from stacked blocks but appear carved directly into the mountains themselves, their stepped terraces and smooth faces defying natural erosion patterns. Russian explorer Ernst Moldashev claimed their alignment mirrors the Giza pyramids, while local legends speak of them as gateways to Shambhala, a hidden realm of advanced beings. What ties these threads together is a culture that saw no divide between science and spirituality. Their medical texts speak of dream physicians who diagnosed illnesses in sleep states, while their pyramids align with celestial events like the summer solstice sunrise. Whether these structures are natural formations enhanced by human hands or something far older remains debated, but one truth is clear. The Tibetans didn't just inhabit their harsh environment, they mastered it, weaving knowledge of earth and body into a tapestry we're still learning to read. The ancient Peruvians didn't just build with stone, they seemed to bend it to their will. High above Cusco, the fortress of Sacsayhuaman stands as a monumental puzzle. Its zigzagging walls composed of blocks weighing up to 300 tons, fitted together without mortar in a mesmerizing jigsaw of angles. What stuns engineers isn't just the size, but the precision. Each irregularly shaped boulder interlocks with its neighbors so seamlessly that you can't slip a razor blade between them. Some stones have 12, even 14 perfectly flush edges, their surfaces smooth to a glassy finish despite being cut from andesite, a rock so hard it dulls modern diamond-tipped tools after minutes of work. How did they achieve this? The mainstream theory involves patient pounding with harder stones and sand abrasion, but experiments show this method would require decades per block. Yet historical records suggest Sacsayhuaman was completed in under a century. Alternative explanations range from the plausible to the extraordinary. Some researchers point to vitrification, where heat or chemicals soften the stone temporarily, a technique hinted at in local legends of plant juices that made rock pliable. Spanish chroniclers wrote of indigenous knowledge involving acidic solutions from mountain herbs, though no such formula has been rediscovered. Others note peculiar marks on certain blocks, small, circular depressions that resemble anchor points for levering systems, suggesting the Peruvians might have employed counterweights and pivots to maneuver massive stones with startling efficiency. Then there's the acoustic angle. Quechua oral traditions speak of sound that moved mountains, and at sites like Ollantaytambo, certain rocks bear grooves that resonate at specific frequencies when struck. Could harmonic vibration have played a role in shaping or transporting these megaliths? Modern experiments with focused sound waves have shown potential to reduce friction, but nothing on Sacsayhuaman's scale. Perhaps most intriguing are the wall's seismic secrets. Peru's earthquake-prone landscape has toppled Spanish colonial churches built atop Inca foundations, while the original masonry stands unshaken. The block's slight flexibility and interlocking keystone design allow them to shift during tremors before settling back into place, an ancient form of anti-seismic engineering modern architects are now studying for inspiration. What emerges isn't just a tale of lost techniques, but a philosophy. The Peruvians didn't conquer stone, they conversed with it, reading its grain and weaknesses like scribes decoding parchment. Their structures weren't imposed upon the land but emerged from it, a collaboration between human ingenuity and Earth's raw materials. When you run your hand along those seamless joins, you're not just touching history, you're brushing against the edges of a knowledge that still whispers just beyond our grasp. The Mesopotamians didn't just invent writing, they weaponized it, turning clay and reed into the world's first bureaucratic revolution. Picture the bustling docks of Ur 5,000 years ago, where merchants from distant lands bartered silver for cedar, lapis lazuli, and spices. Without a way to track these transactions, chaos would reign. Enter cuneiform, wedge-shaped symbols pressed into damp clay tablets, born not from poetry or prophecy but from pure necessity. The earliest examples aren't epic tales, they're grocery lists. temple accountants needed to record grain deposits, livestock trades, and labor rations, so they developed a system of pictographs that evolved into abstract script. Over centuries, these markings grew sophisticated enough to capture loans with interest rates, court rulings, and even complaints. One tablet from the city of Umma fumes about a copper delivery gone wrong, proof that bureaucratic frustration is timeless. But their genius wasn't just in recording, it was in organizing. At Nineveh's royal library, 30,000 tablets were catalogued by subject, with summary tags and shelving systems rivaling modern libraries. Scribes used cylinder seals as signatures, rolling intricate designs onto contracts like personal QR codes. Legal documents included clauses for breach of contract, with penalties calculated down to the shekel. One lease agreement from Babylon specifies that a tenant must repair any wall damage while the sun is high, implying standardized work hours, the real game changer. The birth of the postal service, clay envelopes baked around sensitive documents, could only be opened by breaking them, an ancient form of tamper-proofing. Couriers crisscrossed empires with these brittle parcels, their routes timed to the hour. A letter from a Mesopotamian governor to his subordinate reads, "Why have you not sent word? Do you not know the king's road is measured in days?" What made cuneiform revolutionary was its adaptability. It recorded everything from medical prescriptions, mixing beer with turtle shell for kidney pain, to astronomy, tracking Venus's cycles. But its true legacy lies in democratizing knowledge. Unlike Egypt's hieroglyphs reserved for temples and tombs, cuneiform was taught in scribble schools to sons of merchants and farmers. Surviving homework tablets show rows of botched characters, with teacher corrections scrawled beside them, proof that education struggles are as old as ink. By etching their world into clay, the Mesopotamians did more than keep records. They built the scaffolding of modern civilization, where law, commerce, and memory could outlive any single ruler. Every spreadsheet, every legal brief, every receipt in your wallet traces its lineage back to those sun-baked tablets. A reminder that the most enduring technologies aren't always the flashiest, but the ones that teach us how to count, argue, and remember. The Phoenicians didn't just sail the Mediterranean, they rewrote the rules of the sea, crafting vessels so advanced they became the shipping magnates of the ancient world. Their ships weren't just wooden hulls, they were floating feats of engineering designed to outpace storms and outmaneuver pirates. Take the Goloi, their signature merchant ships. With rounded hulls for maximum cargo space and a single square sail reinforced with linen, these workhorses could haul up to 400 tons of goods equivalent to 300,000 amphorae of wine or olive oil. But what set them apart was their dual-purpose design. By day, they sailed with the wind. By night, crews switched to oars, allowing them to navigate even when the breeze died. This wasn't just convenience, it meant Phoenician traders could keep schedules so reliable their clients timed harvests around their arrivals. Navigation was their other masterstroke. Without compasses or star charts, Phoenician pilots used a technique called dead reckoning, tracking speed, time, and wave patterns to estimate position. But their true secret lay in celestial markers. The North Star, known to them as the Phoenician Star, anchored their routes, while the sun's midday shadow, measured by gnomon rods, helped them track latitude. Some scholars believe they even used a primitive form of the camel, a navigation tool later perfected by Arab sailors, a rectangular board with a knotted string to measure star angles. Their most daring innovation, the bireme, a warship with 2 banks of oars that could reach speeds of 10 knots. Unlike sluggish cargo ships, these sleek predators were built for raiding and defense, their bronze rams capable of splintering enemy hulls. Yet even their warships served trade, escorting convoys through pirate-infested waters. But the Phoenicians' greatest legacy wasn't just their ships, it was their daring. They sailed beyond the Pillars of Hercules into the stormy Atlantic, reaching Cornwall for tin and West Africa for gold. One expedition, commissioned by Pharaoh Necho Roman II, allegedly circumnavigated Africa, a feat Europeans wouldn't repeat for 2 millennia. Their voyages weren't just journeys, they were the first threads in a global trade web, proving the world was far larger and far more connected than anyone had dreamed. The Assyrians didn't just conquer, they engineered fear itself, revolutionizing warfare with a brutality so calculated, it still chills the spine. From the heart of Mesopotamia, they forged the world's first true military-industrial complex, where innovation served one ruthless purpose: absolute domination. Their siege tactics alone rewrote the rules of engagement. Before the Assyrians, armies starved cities into submission. The Assyrians, they brought the walls down, literally. Their battering rams weren't crude logs, they were multi-story wheeled fortresses, armored with wet hides to resist fire and manned by crews shielded in iron-plated cabins. At the Siege of Lachish, reliefs show these monstrous machines flanked by archers firing from mobile towers, while sappers tunneled beneath fortifications. A synchronized assault of force and subterfuge that crushed resistance within weeks. But their genius for destruction didn't stop at physics. They pioneered psychological warfare, broadcasting their cruelty to paralyze future foes. Prisoners were impaled on stakes outside conquered cities, their skin flayed and displayed like tapestries, a grotesque billboard advertising Assyrian might. Yet even these horrors were eclipsed by their most insidious weapon: poison. Scrolls from Nineveh detail recipes for toxic smoke, a lethal blend of belladonna and arsenic burned in clay pots and hurled into besieged towns. Victims described hallucinations, suffocation, and agonizing deaths, an ancient precursor to chemical weapons. Archaeologists at Dura Europos uncovered tunnels where Assyrian soldiers had ignited sulfur and bitumen, choking defenders with fumes centuries before Rome's legions adopted similar tactics. Precision extended to their logistics. The Assyrians built the first paved military roads, enabling chariots to race across empires at 15 miles a day. Relay stations stocked with fresh horses and weapons turned supply lines into a relentless conveyor belt of war. Their messengers, using a proto-pony express system, could deliver orders from Nineveh to the Mediterranean in less than a week, a communication network unmatched until the Romans. What truly set them apart wasn't just their cruelty, but their cold, bureaucratic efficiency. Every campaign was meticulously recorded on clay tablets: rations for soldiers, maintenance schedules for chariots, even the exact number of arrows fired in battle. This wasn't chaos, it was industrialized war where every scream and shattered wall was part of a calculated equation. Their innovations didn't just win battles, they birthed an empire that ruled through terror, technology, and an unflinching understanding of human weakness. To face the Assyrians wasn't just to fight an army, it was to stare into the abyss of war's darkest possibilities. The ancient Carthaginians didn't just rule the waves, they bent the sea itself to their will. Nestled along the North African coast, their capital's circular harbor wasn't just a docking bay, it was a naval fortress disguised as infrastructure. At its heart lay the Carthon, an artificial island ringed by dry docks capable of sheltering 220 warships beneath camouflaged roofs, a stealth advantage that let their fleet vanish from prying eyes. But what truly stunned archaeologists were the hydraulic systems unearthed in its ruins. Sluice gates controlled water levels with precision, allowing ships to be floated in for repairs, then drained for maintenance without ever leaving port. This wasn't just convenience, it was a logistical symphony that kept their navy perpetually battle-ready. Then there's the mystery of the divers. Greek historians like Thucydides whispered of Carthaginian salvage crews recovering cargo from sunken ships using hollow reeds to breathe underwater. Modern tests show these tubes, likely coated with wax for waterproofing, could function as primitive snorkels in calm waters. But a lead tablet discovered near Carthage mentions something far more intriguing: skin bags of air weighted with stones. Some researchers argue this describes early diving bells, inverted containers trapping breathable air when lowered into the deep. If true, it would explain how Carthaginians salvaged anchors and treasures from depths exceeding 100 feet, a feat thought impossible before modern scuba gear. Their maritime innovation extended to navigation. While Phoenician ancestors relied on stars, Carthaginian pilots charted currents and tides with an almost obsessive precision. The Periplus of Hanno, a surviving logbook, details a voyage down Africa's west coast using coastal landmarks and sediment patterns to navigate an early form of hydrography. They even exploited bioluminescence, noting how certain algal blooms clustered near specific latitudes, turning the ocean itself into a glowing roadmap. But perhaps their most chilling invention was reserved for war. During the siege of Syracuse, records speak of Carthaginian fire divers who swam beneath enemy ships to attach incendiary devices. Greek accounts describe flames erupting from the waterline with no visible attackers, a tactic suggesting underwater delivery systems, possibly using buoyant, slow-burning compounds like naphtha sealed in animal bladders. What made the Carthaginians extraordinary wasn't just their technology, but their ruthless pragmatism. Every innovation served a dual purpose, trade or conquest. Their harbor wasn't just a shelter, it was a trapdoor for sudden naval strikes. Their divers weren't just salvagers, they were saboteurs. Even their famed purple dye, harvested from sea snails, funded an empire while symbolizing royalty's blood ties to the sea. When Rome finally razed Carthage, they didn't just destroy a city, they erased a maritime intelligence so advanced, its fragments still hint at secrets lost beneath the waves. The Scythians didn't just ride across the steppes, they ruled them with a mastery of metal and mobility that left even the mighty Persians and Greeks in awe. Nomadic by necessity, these fierce warriors turned the vast, unforgiving grasslands into a domain of innovation, where survival depended on technology as much as tactics. Their metallurgical prowess alone rewrote the rules of ancient warfare. Scythian smiths forged swords and arrowheads from alloys so advanced, modern labs struggle to replicate their durability. The secret, a unique blend of iron and carbon, heated in clay furnaces with bone ash to create a primitive form of steel centuries before the process was perfected in medieval Europe. But it wasn't just the material, it was the craftsmanship. Their signature echinix daggers balanced weight and lethality with a tapered design that could pierce armor, while their arrowheads, often dipped in a lethal cocktail of venom and feces, turned even glancing wounds into death sentences. Yet their brilliance extended far beyond weapons. The Scythians engineered a nomadic lifestyle so efficient, it became a blueprint for steppe empires to come. Their yurts, constructed from felt-covered lattice frames, could be dismantled and loaded onto wagons in minutes, transforming entire cities into mobile caravans. These weren't just tents, they were insulated marvels with layered wool walls to withstand sub-zero winters and smoke holes designed to ventilate without sacrificing heat. Even their clothing doubled as technology. Trousers, a radical innovation for the time, allowed freedom of movement on horseback, while their pointed caps, often lined with gold foil, acted as primitive solar reflectors in the scorching summer. What truly set them apart, though, was their symbiotic relationship with the horse. The Scythians didn't just tame these animals, they redefined them. Their steeds, bred for endurance and speed, could cover 60 miles a day, outpacing any settled army. But the real game-changer was their saddle, a wooden-framed design with stirrups made of woven rope. Though not the rigid metal stirrups of later centuries, these early versions gave riders unprecedented stability, enabling them to fire arrows with pinpoint accuracy at full gallop. Combine that with their composite bows crafted from layers of wood, horn, and sinew for unrivaled power, and you had a cavalry force that struck like lightning and vanished like smoke. Their artistry reveals another layer of sophistication. intricate goldwork recovered from burial mounds like the famous Tolstoy Mogila showcases a style both brutal and exquisite. Animals twist into combat in swirling motifs, a technique later adopted by Celtic and Viking artisans. But this wasn't just decoration, it was propaganda. Scythian elites wore these golden adornments not only to display wealth but to project an almost supernatural authority, a fusion of art and intimidation. The paradox of the Scythians lies in their legacy. They left no cities, no written records, just echoes in the soil. Arrowheads buried in Persian battlefields, horse tackle scattered across the Ukraine, and golden stags staring defiantly from museum cases. Yet their influence rippled across millennia. The Mongol hordes, the Turkic empires, even the Cossacks, all traced their tactics and tools back to these vanished masters of the steppe. To understand the Scythians isn't just to study a culture. It's to witness the birth of a nomadic ethos where survival, innovation, and artistry galloped side by side across the endless grass. The Etruscans didn't just build cities, they sculpted them into the earth with an almost supernatural understanding of water and stone. Long before Rome's rise, their hilltop metropolises boasted grid-patterned streets, sewage systems, and subterranean tunnels so advanced, later civilizations assumed they'd been gifts from the gods. Take the city of Spina, a bustling port now buried under centuries of silt. Archaeologists mapping its foundations found something startling. The entire settlement was laid out like a spiderweb, with canals instead of roads, and houses perched on wooden pilings driven deep into the marshy ground. This wasn't haphazard construction, it was a deliberate adaptation to the Po River Delta's floods, turning a watery threat into a strategic advantage. But the real marvel lies beneath their feet. The Etruscans engineered cuniculi, a network of narrow, vaulted tunnels that snaked for miles through solid rock, funneling water from springs to farmland with gravity alone. Unlike Roman aqueducts which marched across landscapes in towering arches, these channels were invisible, hidden underground to prevent evaporation and enemy sabotage. Some shafts descended vertically like wells, then branched horizontally with precise gradients, proving the Etruscans didn't just move water, they calculated its flow down to the droplet. Modern hydrologists testing these systems found they could irrigate entire valleys without pumps, a feat requiring an intimate knowledge of geology and physics. Their urban planning was equally visionary. At Marzabotto, streets aligned not just with cardinal directions but with solstice sunrises, while temples were positioned atop natural magnetic anomalies. Draftsmen used bronze compasses and grommers to plot right angles, yet their designs incorporated curves and terraces that harmonized with the landscape. The result, cities that felt organic rather than imposed, where drainage channels doubled as sacred pathways, and rainwater collected in cisterns was filtered through layers of charcoal and sand, a primitive purification system centuries ahead of its time. Then there's the mystery of their metallurgy. Etruscan artisans crafted bronze mirrors with reflective surfaces so flawless, modern conservators initially mistook them for Victorian replicas. Their secret, a polishing technique involving crushed quartz and oxide buffers, passed down through guilds that guarded their methods like state secrets. Even more baffling are the Tom Adotto tomb walls adorned with metallic paints that still shimmer after 2 millennia. Chemical analysis reveals traces of zinc and antimony elements not formally identified until the Middle Ages. What makes the Etruscans truly enigmatic is how much they achieved without leaving manuals. Their language, partially deciphered, hints at a culture obsessed with divination and celestial cycles, yet their technical treatises vanished when Rome absorbed their civilization. Were they mere innovators or inheritors of a lost knowledge? The answer might lie in their greatest legacy, teaching the Romans everything from arch construction to hydraulic engineering, only to fade into history's shadows as their pupils claimed the spotlight. What if everything we've been taught about the timeline of human progress is missing entire chapters? From the moment we stepped into the world of the Sumerians and their celestial calculations, to the floating harbors of Carthage and the self-healing concrete of Rome, one truth becomes undeniable: our ancestors weren't primitive. They were pioneers. Each of these 25 civilizations didn't just exist alongside history. They rewrote it, bending stone, metal, and the very stars to their will with innovations that still leave engineers and archaeologists speechless. Think about the implications. The Maya predicted eclipses within seconds without telescopes. The Indus Valley engineered sewer systems when most of the world drank from muddy rivers. The Nabateans turned deserts into oases with nothing but gravity and stone. These weren't isolated flashes of brilliance. They were sustained explosions of ingenuity, proving that advanced technology isn't linear. It's not a straight path from primitive to modern. It's a labyrinth of rediscovery where entire systems of knowledge can rise, vanish, and rise again under different hands. And yet, the most humbling lesson isn't just what they achieved, it's how little we truly understand. The Olmecs moved 20-ton heads through swamps without wheels. The Egyptians cut granite with drills that, by all rights, shouldn't have existed. The Scythians forged steel in open fires centuries before medieval smiths. How many of their secrets were lost to war, disaster, or simply the passage of time? How much of what we call cutting edge today might just be a rediscovery of ancient mastery? This isn't just about marveling at the past, it's about questioning the present. If they could achieve so much with so little, what does that say about our own potential? Maybe the real mystery isn't how they did it, but why we ever assumed they couldn't. Now it's your turn. Which of these civilizations stunned you the most? Do you think they stumbled upon these breakthroughs by chance, or is there a deeper story waiting to be uncovered? Drop your theories in the comments, because history isn't just a record of what's been found. It's a conversation about what's still out there, whispering to us from the shadows.